Hello everyone. So in the last lecture, we have covered regarding linear search and binary search, the concept wise. So today we are going to write the code for a linear search and binary search. So you already know like the linear search works on an unsorted array. So the first question is given, write a program to search element 10 in the given array. To search the given element, that means you are told to find the index, to search the element 10 and find the index, okay, in the given array. This is the given array. All right, so how we are going to do, so I have already explained the concept of a linear search. What we'll be doing, we'll be going ahead one after the another to the each index in an array. Okay, so first here, if you see, array is already given, so you don't need to take input. Okay, so what we'll do, we'll directly go over here and like what we'll do, we'll apply a loop for loop. But before that, you have to initialize an array with these element that is already given. So you will take one input. This is the key that you need to search. Okay, this 10 you have to search in the array, that whether it is present or not. Let's name this variable as a key, and this key that we have to search is 10. All right, now you have to create one array with these elements. Okay, so we'll create one array, int arr is equals to new int, and in this we'll give the size. So how many elements are present? 1, 2, 3, 4, 5 and 6. So we'll give the size as 6. But when we do this, we generally do this when you have to take input from the user. Got it? If the elements of the array is already given, this is not required. Okay, this is not required. This way will not do. We'll directly hard code it. How we are going to do, we'll say arr is equals to, and then curly braces, and in the curly braces we'll give this numbers. Okay, as comma separated, like index 0 will have 90, index 1 will have 40, index 2 will have 88, index, then next index will have 20, similarly 10, and then 20. All right, so now we have created one variable with the key that we have to search, and we have initialized the element in the array. So in the index 0 it will be 90 and so on. All right, now you, what we have to do, we have to apply a loop. Okay, so we are going to start from index 0, int I equals to 0, and then what you have to do, index arr dot length. We can do either arr dot length. This is the property available inside array. Okay, so we can directly do arr dot length, then I plus plus. So this is available for arrays. You can directly do arr dot length, or you can remove this and you can directly write the size like 6. But you should know there is a property available that we can use, that array. This is an array. So if we do dot, so we get the property. We can directly call that. So that is array dot length will return 6. So after calling this, this will return 6. So you can assume here it is 6. Okay. All right, now what is happening? After that, we have to iterate in the loop and we have to find whether that element key is present or not. So what we can do, we can create a flag. We can create a flag, int flag is equals to, we'll say int flag equals to -1. So generally when you do searching and all, you take the flag as -1. And if that element is found, you will initialize that with the index. Okay, so let's see how. So you'll say if arr of I, so arr of I, this index 0 is double equivalent to, that means is this 90 equivalent to this key, double equals to key. All right, if this is equivalent to key, we will say flag is equals to I. All right, flag is equals to I. So the flag value initially was -1. Now the flag value will be, if it is found at index 0, it will be 0. If it is found at index 1, the flag value will be 1, but it will be greater than this. So what you can do, if you will not break the program, what will happen? Suppose 10 is found here. So again you are going to this, again you are going to this, again you are going to this, and checking whether that element present or not. Okay, so what you can do, you can apply a break over here. So whenever you find that element, this is more efficient code. Suppose you found that element in the index 1, then and there only you are stopping this loop. Okay, if you are not applying break, if you are not applying this break, then what will happen? Suppose even this element 10 is present in the first index, still it will iterate through the whole indexes. Okay, so to write a better solution, to write a better program, you should break it. Like if you have found that value in a particular position, let's break it, will not move ahead, because the question was to find the index. So we have already found the first index, okay, generally first index. Then if you are told to find the, there can be some first or the second index similarly like that, so generally the question comes like, generally it will say you to find the index. It will not say that suppose there is two position, the element is present, find the second or something, the first or the third. It will not say like that. Okay, but even the question is regarding find the second index of a given element 10, so you can generally do that. So you have to create one more flag, and then you have to check which index it got, or again you have to do something like that, but this is out of your scope. You have to think whenever you get the first index, that's it, we'll break the program and we will check. So suppose it is found at this first index, so it will break from here, and what will be the value of flag? Value of flag will be 1, that is the index, because the I contains the indexes. Okay, now suppose if it is, suppose I have to find element 15, and that 15 is not present inside this. So what will happen? The flag value will still be -1. So after coming out of this loop, we will check if flag, if flag is greater than -1, that means we have found that element. If flag is greater than -1, that means we have found that element. If not, then we will say element not found. So we'll say found at, found at index, found at index plus flag. All right, so we'll say we found that element at the index flag. All right, now if it is not found, we will say else it is not found, and will display the output system dot out not found. Okay, so we'll say not found. All right, so this is a complete program that we have written, and then let's try to run it and check whether we are getting the output or not. Okay, so it is running. So you see found at index 4. So you see where that element 10 is present. It is present at 0, 1, 2, 3, 4. All right, so you have given the output like it is present in the index 4. Now suppose if we want to search for some other element, suppose 15, that is not present. Okay, so what you will do? So for 15, if I run it, the answer should be not found. Let's check what is the output. Not found. That means we have successfully implemented a correct logic for a linear search. I hope you got this. You can take a note of it. All right. Okay. So this is a closing after the loop. So you have to keep in mind, after the loop, we will check for the condition. If it is present, then we'll output like it is present at the given index. Else we will say it is not found. All right. Now, the second program says you have to implement a binary search. Here it is given, write a program to search 10 in a given sorted array. So you have already told like the array is sorted, even that word sorted is not present, and you see like the elements are sorted in the descending order. That means you have to implement binary search. Okay, so let's quickly go and solve this problem. All right, so we'll again go to this part, and for binary search, let me copy this question. Okay. So as you know, like for binary search can only be applied to a sorted array, even if it is in descending or in ascending order. Only the logic will change. If it is a descending, then the start and the left pointer we have to move accordingly. All right. So let's see. So what you will say, will create one array intarr and will initialize with these values like comma separated values. So these values will be 70, 60, 40, 30, and so on. And now suppose what is the key? You have to find the key as 10. All right, this is what you need to find. Now we'll implement the binary search. So I told you we will iterate in the loop until the start reaches to the end. So we marked this as a starting pointer. This we in the last class I told you we'll mark this as a start and we'll mark this as a end. All right. Now what will happen? We will go to the mid. First we'll find the mid, and then accordingly we will move the start forward or we'll move the end backward. So that was the logic that I told you. All right. So we will say we'll create two pointer int start, and the start should be at the index 0. Start should be at the index 0, and end should be at the last index. End should be at the last index. That is arr dot length minus 1. So where it should be present? End should be at the arr length minus 1. So length will be 1, 2, 3, 4, 5, 6. So the last index is 5. So we are doing arr dot length minus 1. That means start is at index 0, start is at index 0, and end is at index 5. All right. Now what I told you, will iterate through the loop, so we don't know the terminating condition exactly, like we'll have to start from 1 and we'll have to go to till 10. So that is the scenario that we don't know. So that is why we'll not use for loop. Instead we'll use while loop. So in while loop, you know only the terminating condition. What is the terminating condition? I told you we will iterate through the loop until this start is less than the end. Starting index is less than the or equal to the end index. Till then we will iterate in the loop. All right. So what we will say if first we'll find mid. Okay, I told you first you have to find mid, int mid. Okay, now you'll say mid mid is equals to start plus end and divided by 2. Basically this mid is an integer value, so you will get the floor division. This mid is an integer value, so you'll get the floor division, you'll not get the decimal part. So here 0 plus 5 will be equivalent to 2.5. So initially the mid will be 2 because we are not taking the decimal part. All right. Now what we'll say, if the arr of mid, that means if arr of 2, that is index 0, 1 and 2, if this value is equivalent to key, if this value is equivalent to key, we will say we found the value at this given position. This is the scenario when we will say we found that element. So we will say system dot out dot println found the element at index, and at which index? We'll say index at mid. All right. So this was the first concept that I already told you. Now if that element is not present in that mid position, what you have to do, you have to either move the starting towards the right hand side or the end towards the left hand side. So how you are going to decide? So you see that the array is in descending order. So what you will say, if the array is in descending order, then what you are going to say, like you'll check if and suppose you found that element, then again I told you you need to break that. Either you can do or you don't do, that is up to you. but you should generally break it if you found the result. Okay, now what you will say, if ARR of mid, now you think of the scenario like you need to find 10, you need to find 10, and at index 2 you got 40. Now you will say the value that I got at that mid, if it is greater, suppose here I need to find 10, and what I got 40, and you know, like this is a descending array, that means my result will be on the right side, smaller number will be on the right side. That means you have to move the starting index towards the right. That is a concept. So you'll say if my mid, the value that I got is greater than what I need to search, then I will move the start is equals to mid plus 1. Don't mug it up. You have to understand the concept. Like if it is a descending array and I found that element is greater than what I need to search, that means my answer lies on the right hand side. That means I have to discard this left hand side. Then what you have to do, if you have to discard the left side, then you have to move the start is equals to mid plus 1. Now suppose your answer lies on the left hand side, then you will keep starting at its position. You will keep s starting index as it is, and you will move the end index toward the left hand side. Got it? Now you will say like if mid, ARR of mid is greater than key, then we'll move the starting index is equals to starting index plus 1. Else else the scenario can be the key is less than the mid value is less than the key. That time we'll do end is equals to mid minus 1. So this is the concept. In the ascending array, here the logic will change. In the, if the array is in ascending order, here it, instead of greater than, here it will be less than. So I'm telling here in ascending array the condition will be ARR of mid should be less than the key. So this is the one thing that you have to change for the ascending array. Instead of this, you'll write this logic. That's it. So you have to check on your own whether the given array is an ascending array or in a descending array, right? Now, so this is a logic we wrote. Now what we'll do, if that element is found, we will say found at the index this. All right. Now, so if it is not found, so we can, how we can generally do that? So we have to again create a flag. So if it is found, we can mark it as a flag. Int flag is equals to -1. Flag is equals to -1. So here we do the flag, and instead of printing here, what we'll do, we'll say flag is equals to mid, because you found that element at the mid, wherever, like second index, third index, fourth index, and you came out of that loop. Now after coming out, you will check if flag is greater than -1, you will say found at index flag. So wherever you got that, you will get that flag value. Okay. Else, if it is not found, you will say not found. So it is very straightforward. You have to just understand the concept. That's it. Not found. Now let's quickly try to run it. So you see found the element at index 5. Let's check. Yeah, it found it. Now let's check for that is not present. Check for 15. So 15 is not present. So it should result not found. Okay, not found. So you see like how many times we are going. If you want to see this, I can have a print over here. System dot out dot print, I can say mid plus mid. So now you will be able to see first where it is going. Okay, mid, see. So first time it will find the mid. First mid will be 2. So see, first it went to the second index, then it element not found, then it went to the fourth index, then it went to the fifth index, and finally it didn't found the result. So you see, like this way it is iterating through the loop, and we are checking whether that element is present or not. So this is a straightforward logic. You just have to remember the concept. That's it. You will be able to apply this logic on your own. Only thing you have to know, when we have to stop it. We have to stop until we move the start forward, 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 and until it reaches the end. That is the terminating condition. And if that, you have to first find the mid, and if we found that mid at that given place, we will break it. If that position element that we got in that place, and if that is greater than what we have to find, then we have to move the start right side. And if it is an ascending array, we have to just reverse this, greater than to less than. All right, that's it. So hope you understood this concept. If not, then I will again explain you in upcoming lectures. Thank you.